So in our last lesson, I introduced you to the idea of a box plot, also known as box and whiskers. That's where I feel like we should mathematically begin, logically, so you understand then how you're finding the interquartile range, which is the IQR, and how we use that information. So continuing on, then, we're going to look specifically at the interquartile range and then review the box plot. And then we're going to talk about how we answer questions regarding comparing these numbers. So when I get into this particular lesson, then now I can start looking at what it is that they are expecting us to learn, right? So we always talk about what is the objective of the lesson here. So when we talk about what I can do is I'm going to be able to use my variations of my data. Well, that's a big fancy word, and we want to know what exactly that means. What is a variation or the variability of the data that's given? So when we talk about variations, we're simply talking about the variability or the spread of the data set. Where is the lowest area, the highest area, and in the groupings that I can come up with, where do they belong? So when we look at those groupings, then we have from highest to lowest, that is the range, the difference between the two. Right? We've talked about mean, median, mode, and range. So I want to be able to find the difference or subtract to find the answers to know the distance between the highest number and the lowest number. Then I'm also going to then start finding the median, and then I have a couple other medians. So the wording in this particular lesson is a little different than what we usually use in sixth grade teaching box plots and what we call them. But we need to start with the idea of what quartiles mean, right? So we have the Greek Latin root word QUA, qua, which means four. When I think of a dollar bill, it's divided into four equal quarters, right? Because a quarter is four. So when we look at how we're going to divide up our data set, we're going to put all of our data into four equal groupings. So each of those are going to be worth 25% of the data. Therefore, we need to know where the median is. We need to know where the lower quartile is, or what they refer to as the Q1. And I need to know where the upper quartile is, or what they refer to as the Q3. So I would make some notes about lower and upper. You might see it listed as Q1 and Q3 on the state tests. You might see the median listed as the Q2 or the second quartile, but generally I think you're going to find them listed as the lower quartile, the upper quartile, and then the median of the data set. So when we start doing this, then we have to look at our measurements. So once again, it's putting everything in order. When I do box plots, box and whiskers, if you will, if I do interquartile zone, I have to have my data in order from least to greatest. Now in our next lesson, when we do the MAD, the mean absolute deviation, they don't have to be in order, but most of the time when I have data and I'm looking at mean, median, mode, range, they've got to be in order from least to greatest, and each one has to be written down. So once we have them in order written down, then I start finding the median. Now, when I find the median and then I plot it, then once again, I cross one off on the left, I cross one off on the right, and we go in pairings until we get to the middle. If it's an odd number in my data set, then the middle number is circled and I'm good to go. But such as this example, in the book that they give you, you have an even number of data set. So you have to take the two numbers, and once again, you have to add them together and divide by 2, because you're actually averaging the middle two numbers. Now, most of us will know by looking at that the middle number between 3 and 4 is 3.5. But we want to be able to prove it because when we get into harder numbers or a wider spread of two middle numbers to find the median, then we have to still know how to do the math. So we take 3 plus 4, which is 7. And when I take the 7 and divide it by 2, because once again I'm averaging two numbers, then I'm going to see that 2 will go into 7 3 times with a remainder of 1. I raise a decimal, I add a 0 and bring it down, and 2 will go into 10 5 times. So we're seeing that our median is 3.5 for this data set. Now, when I have 3.5 then, and I remember the steps of finding the box plot, then once I have it, I'm going to mark it on my number line where 3.5 would be with a tally mark. So that's going to be one of the lines inside of the box when I make my box plot. When I then do my lower quartile, or as this book calls the first quartile, the Q1, then I have to go to everything on the left of the median. Now I draw that line. Now mine's in green, yours will be in charcoal because you're using a pencil, but I draw the line to indicate where the median is. I make it nice and big so that I know everything to the left of that has to be used to find the lower quartile, or once again, as the book says, a Q1, because I'm going to find the median of that group now. So everything on the left-hand side, I'm going to work crossing off one on the left, one on the right in groups of 2 until I find the median of that group. Well, the median of that group is in between 1 and 2. You probably know that that's 1.5, but when we do the math to prove it, then we have 1 plus 2, which is 3, and 3 divided by 2 is going to be 1 with a remainder of 1. So I add my decimal. I add a 0 and bring it down, and 2 goes into 10 5 times. So I see that my lower quartile is indeed 1.5. And then, as the steps on the box plot handout shows you, then we're going to just make a tally mark where the 1.5 would be. Now, I have to do the Q3, as the book says, or what I refer to, and you'll probably see more often, as the upper quartile. So the upper quartile is I have to go to the right of the median. And once again, the median is that big slash in the middle that's labeled 3.5. So I have to include the 4. So everything on the right, then I work towards the middle. I see that I have 2 middle numbers, 6 and 7. So the median of that group is going to be 6.5. Now I know that because when I add 6 and 7 together and I get 13 and I divide it by 2, I'm going to see that it is indeed 6.5. So my upper quartile is 6.5. I make a tally mark according to the steps of my box plots. Now, once I have that information, then I have to look at how I'm going to use it to answer the questions that are being provided. So when we talk about the interquartile range, all right, so range is the distance from the highest number to the lowest number. The interquartile range is looking at the 2 middle quartiles, the 2 middle quarters, or 50% of the data that we've collected. So from the Q1 up to the Q3, according to how the book labels it, or as I would call it, from the lower quartile up to the middle quartile. So when we're asked to describe this type of information, then I have to state that the middle 50%, or what I just use the words the middle half, is so that I can indicate the information. When I see that my upper quartile is 6.5 and I see my lower quartile is 1.5 and I subtract those, then what I'm seeing is that I have an inner quartile range, right? So the distance from the highest to the lowest of 5. So as we're doing these, we're looking at specifically the box for the box plot as we're doing the data set. And then we get into making the box plot. So once again, that's why in our previous lesson, we went over what a box plot is and how we create them. But as we're doing these, we have to put them in order from least to greatest. So on this example from this data set, I can see we're talking about different animals and their average speed that they can run. So I put them in order from least to greatest, and I see the spider is going to be a 1, and so I get rid of that data. And then an 8 for the mouse, and then I have 25 for an elephant, so we definitely have a jump there in our speed. We have a 30 for the house cat, and then we get into the big cats. We have a lion at 50, sorry, lost my focus, and the cheetah is at 70. So I look at how many pieces of data I have. I have 6. I have 6 written down. I'm good to go. So now what we're looking for is being able to find the range. And once again, the range is the distance from, or the difference of, the 70 and the 1, or the highest data to the lowest data. So when I subtract those, then I can see that 70 minus 1 is 69. So if I'm describing that information, I'm describing the variation, I'm describing the spread of the data, as we saw on the first page of notes, then I know that they are going from 70 miles per hour as the fastest all the way down to the slowest of 1 mile per hour. Now notice these are sentences. On your assignment, you're going to be expected to write these sentences. And on these examples, I'm going to give you the same type of answer each and every time. So when I talk about the range, I'm going to indicate the fastest and the slowest, the highest and the lowest, whatever two numbers we're going to use for the range, and then I indicate what the range is, because range is always a measurement. I want to look at the data and figure out what the label is. So a complete answer to describe part A is the fastest animal goes 70 miles per hour and the slowest goes 1 mile per hour. The range of speeds is 69 miles per hour. Now we're going to look at the second part, and we're going to talk about the interquartile zone. So the interquartile zone has to start with building the box to a box plot. So we have to first find the median of the group. So step one, we find the median. So we cross them off left and right to find our middle two numbers, which are 25 and 30. Once again, we add those together and figure out what that median is of the data set. So when I add those together, I get 55. I'm going to divide 55 by 2, and I have 2 with the remainder of 1. So 15 by bringing down the 5, and 2 goes into 15 7 times with the remainder of 1. Once again, I want to add a decimal, a 0, and then bring down the 0, and 2 goes into 10 5 times. So the median of the group, the median of all the data, is 27.5 miles per hour. Now we need to find the lower quartile and then the upper quartile and find their range, right? So we subtract those and find their difference. That's what the interquartile range is. That's always going to be 50% of the data. So with that middle line splitting the data group, then I know everything to the left is going to be used to find the lower quartile. Well, since there's only 3, I can cross out 1 on each side and I'm left with an 8. That makes my life easier. I don't have to do the math. Same thing on the right, because my lower quartile is 8, then my upper quartile is going to be the middle of the second half of the data. So when I get rid of the 30 and the 70, I'm left with a 50, once again making my life easier because I don't have to do the math to find the median of that group. But what we're seeing then is that the lower quartile is 8, the upper quartile is 50. And when I want to find my interquartile range, once again, what is the middle half? The middle 50% of the data. Where are they going to be found? Well, they're going to be found in a range of from 8 to 50, which is a range, right? A distance, a difference of 42. So when we describe that, then we come up with one or two sentences. We can make it into one sentence. The middle half of the data, and once again, I always start with the middle half of the data. You can say the interquartile zone is found in, or the middle 50% of the data is found in. But I indicate that it's the middle half. That way I know it's the interquartile zone, and it's between the highest and the lowest, or the lowest and the highest of that grouping. So that's the 8 and the 50. And then I tell what that range is. So that is a range of, so the middle group, that's an interquartile range. I would subtract those. 50 minus 8 is 42. All right, so before we move into this particular check question, and I'm going to lead you through this one. I'll give you one to do at the end of the lesson when it comes to the box plots, but I'll walk you through this. But I want you to stop and think, because I know some of you, you're struggling already. It's been 12 minutes and your focus is gone. I know this because, once again, I've lived my entire life with ADHD. I know that it took me forever to understand how my brain works when it comes to learning and how much extra work I have to do in order to learn something. Still, at 51, 52, I have to go and rewatch things and reread things multiple times to get all the information that I'm trying to learn from it. So I'm asking you to be able to do the same thing. If you did not understand, you did not pay attention, you did not follow along, all you did was copy down what you saw on the previous question, and you don't really know where it came from, then I would really like you to go back and rewatch it. I'm going to give you all the time in class today to take notes, and this will not take the entire period for the video. So I build in time for you to go back and rewatch for those of you that struggle like I do when it comes to being able to focus. So it's just simply going to take your efforts and your desire to do well in order to do well. I can't do it for you. All right, so we're going to get into this. So when I'm looking at some information, I see a data chart, I see a question, and I see a part A and part B. So let's read what the word problem is telling us, and let's cube it up so we can understand what we're being asked to do. So once again, we put boxes around key science terms, right? And I see the average wind speeds for several cities in Pennsylvania are given in the table. Right, so we got that table over to the right. Use the range, that's another math term, and the interquartile range, that's a new one that we've learned, to describe how the data vary. So we're being asked to do two different things. Use the range and interquartile range to do what? To describe how the data vary. So hopefully when we see that word describe, we're thinking, oh, I know what part of my answer has to be in words, specifically in complete sentences, because we're sixth graders and we can do that. So how am I using average in this question? Well, the average is already given to us in our table, so there isn't anything mathematically that I have to do with average. So when we mark up a word and we find out once we start thinking about what we're asked to do, and it's not important information for us, that we don't have to do that, I cross that out so I know that I'm not going to get distracted with it. Once I know what I'm looking for, then I have to go through the process to find the range. And once again, we have to start these going in the same order, not just for the interquartile zone, but when I continue on and make the entire box plot or box and whiskers. So I have to put my data in order from least to greatest, because range is finding the difference between the highest and lowest number. And then the interquartile range is finding the distance between the two quartile measurements. So having them in order is necessary in order to be successful. So when I look at these wind speeds, I have 7.5. I get rid of it, 7.6, cross it out, 7.7. 8.9, 9, 9.5, and then 11. All right, so I had 1, 2, 3, 4, 5, 6, 7 cities. I wrote down 1, 2, 3, 4, 5, 6, 7 numbers. I'm pretty sure I have them all, and they are in the correct order according to a number line. So in order to find the range, then I do the math of subtracting the highest and the lowest numbers. So I have 11 and I have 7.5. Once again, I have to put my highest number on top because it is a subtraction problem. I can't take from 0, so I have to borrow. But before we do that, we need to bring down our decimal to make sure we don't forget it, because then our number is not logical. So we'll be reviewing how to add and subtract decimals during success period. But just make sure that our first step is always to line up the decimals and then bring it down. Now I can go through and say, well, I can't subtract 5 from 0, so I'm going to borrow. When I borrow, I cross out the number and I go one number below, so from 1 to 0, and then I carry the 1 over, and now I have a 10. I can definitely do that, and if I'm not sure if I can do that, I hold up 10 fingers, and I take 5 from it, and I have 5 left. Now I have 0 minus 7, and I can't do it, so I would borrow, or I can just see that that is 10 minus 7, and 10 minus 7 is 3. So I know that when I look at my range, right? So this is the second part. I have to describe it. I have to use words and sentences, complete sentences. So I would say that the fastest wind speed was 11 miles per hour, while the slowest was 7.5 miles per hour. Now you can get more specific and give the names of the cities if you want, but it's not required. But that's just indicating the numbers that I'm using. Now I have to actually give the range in a sentence. I can make a complex sentence and put it in there and make one big sentence, or just have two of them. But then I have to tell in words what the range is. So that puts the wind speeds all in a 3.5 mile per hour range. because once again, I subtracted the highest and the lowest ranges and got 3.5. Now, as we see, we also have to find the interquartile range. And the interquartile range is going from the median of the group. So I have to start from the median. That's my first step. They're already in order from least to greatest, so I'm good to go. And since it's an odd number in my data set, I have a middle number, which makes my life easier. So I know the median is 8.9. When I know that my median is 8.9, now I have to find my lower quartile and my upper quartile, because my interquartile range is the distance from lower to upper. So when I do that, I'm finding the middle of the left-hand side of the median. Since I've circled the 8.9 as my median, I'm not going to include that to find my middle lower quartile. So I'm going to just use the 7.5 to the 7.7. I have 3 points of data. I cross one out on each side, so I'm left with 7.6. That's my lower quartile, or as the book would indicate, my Q1. When I do, excuse me, my upper quartile, then I have to go to the right of my median. Once again, I've used the 8.9, so I'm not going to include that as I'm going to find the middle of the upper quartile group. So, sorry about that. So I'm going to cross off on left and right, and I see that I have 9.5 left. My Q3, or my upper quartile, is 9.5. So once again, our interquartile range is the middle half of the data, or the middle 50% of my data. So what we're saying then is, if I subtract those, because we're finding an interquartile range, I have 9.5, I subtract the 7.6, I bring down my decimal because I'm subtracting decimals. I can't take 6 from 5, so I have to borrow. The 5 becomes a 15, and 15 minus 6 is 9, and then 8 minus 7 is 1. So my interquartile range is 1.9 miles per hour, but I'm describing it, so I have to use a sentence. So I would say the middle half of the data falls within a range, you could say a middle or an interquartile range of 1.9 miles per hour. All right, so as we're doing these, we're looking for math to be shown, it's worth points, and I'm looking for sentences to describe the range in the interquartile range, and each of those are worth points. So now we're going to return to the idea of box plots, or sometimes called box and whiskers. All right, so when I'm looking at the box plot or the box and whiskers, then hopefully we notice that from our previous lesson that we did, that our first few steps of finding the box plot is the same thing as finding the interquartile zone. Now, once again, they have some different labels on here than I would ever use. So what I would suggest is that you add some notes to this image that's in your book, so that you know that when we're talking about the lower extreme, what we're talking about is the smallest data that's included in the data set. And then when we're talking about our Q1, that we're talking about our lower quartile. Our median is our median. Our Q2, as they're showing, is our upper quartile. And then our upper extreme, which I would never call it that, we just call it our largest number, our largest data. So if you mark that up, then you'll know what we're talking about and what they're referring to, because I will probably not use those terms because I never have before. All right, so when I have a box plot, so when I'm looking at this box plot, then I can get some information from it, and there's some information I can't get. Do I know how many measurements were taken? No. Do I know what the average measurement or the mean measurement is from this data? No. Do I know the median? Yeah, I do know the median, don't I? Right? It's a little over 160. Do I know the lowest measurement? Yeah, it looks like it's right above 110. Do I know the upper measurement? Well, it looks like it's right below 250. Right? I also know that when I'm looking at a box plot, so when I look at the left whisker, that's 25% of the group. When I look at the left-hand side of the box, that's 25% of the group. The right-hand side of the box, that's 25% of the group. And then the right whisker, that's 25% of the group. So once again, when we're finding quartiles, we're putting all of our data into 4 equal groupings, and that's what a box plot does for us. So when I look at the middle, the box, it's always going to represent 50% of my data. And the 2 whiskers, when I look at those and add those together, they're always going to equal 50% of the data. So when I'm looking at the box itself and I see that it's always divided between the lower and the upper parts of the middle group, then those are always going to be equal to 25%. It doesn't mean the box is divided by the median in half. We just know that 25% of the data is on the left side of the box, 25% is on the right side of the box. All right? So when I start describing the distribution, when I'm describing how the numbers are spread out, then I'm using words once again. So here are 3 common questions that you're going to be answering on your assignments and on your upcoming test for Unit 10. What can you tell about the range of the average snowfall amounts? So the range, once again, is going from the lowest to the highest. So we're going to say, we're just going to make that a nice even 110. And then when I look at the other one, it's not quite 250, so we're going to say 248. So when they aren't exact, then, your answer is going to be within 1 or 2 probably when it comes to your subtraction problem. And that's okay, right? If they don't give me exact numbers, then I have on my answer key some approximate answers that you should get. If you're completely off by like 10 or 100, then we got some major issues. So when I'm going to take 248 and I'm going to subtract 110, when I subtract those, I get 138. So what can I tell about the range of the average snowfalls? Well, I'm going to say that the greatest snowfall was about, notice the keyword about, 248 inches, whereas the smallest was 110 inches. And then I tell what the range is. That gives a difference in average snowfall range of 138 inches. The second question we're going to look at. What can be told from the interquartile range? How can I describe it? What words can I use? So when I look at my interquartile range, then I'm looking at, we're just going to say that's 143. And when I look at the upper part of the box, we're going to say that's 195. Once again, it's not going to be exact because they don't give me exact measurements, but I should be pretty close. So I'm going to take 195 and I'm going to subtract the 143. And when I subtract those, I know 5 minus 3 is 2, and 9 minus 4 is 5, and 1 minus 1 is, well, that's nothing. So what I can tell in words about my interquartile zone, once again, I always start with the middle half of the data falls within a range of 52 inches going from, and then I'm telling the 2 numbers that I used for my interquartile range, 143 inches to about 195 inches. But there's going to be a third question that we're going to answer on our assignment and on our test. Hopefully you're writing these 3 questions down somewhere. According to the data, where are the snowfall averages more consistent or most consistent? So when we go to the idea of consistency, we're asking, where is the data grouped together the tightest, right? Is it more clumped together in the whiskers, or is it more clumped together in the box? That's what it's asking. So there's several different ways you can figure that out. You can draw and measure with a piece of paper. You can use a ruler. Some of you can eye it and see that the box is actually smaller than the whiskers. So I've just pulled them out to the side there and showing you that if I truly have a measurement where I'm putting the whiskers together, the whiskers are considerably longer than the box itself. So when I can see that, then if it's tighter together, if it's more clumped together, then I know that that's the part that's more consistent. So on this third answer, it's either going to be that the box data is more consistent, the interquartile area, or the whiskers are more consistent. And it just depends on which group is tighter or more clumped together. So I'm going to answer the third question in a sentence. It is more consistent that the snowfalls fall, that's a little tricky, between about 143 inches to about 195 inches. I could say it shows that it's more consistent that the snowfall would be in the interquartile range, or in the inner 50% or the inner half of the data. So there are different ways to word it as long as I have an accurate answer. So when I look at this, then it says we're looking at this average of gas mileage. This is my box plot. Once again, can I figure out what the mean or the average is? No. Do I know how many pieces of data there are? No. What can I tell? Well, I can tell the three questions we're going to ask. Describe the range, describe the interquartile range, and describe which is most consistent. So what can be told about the range of these average gas mileages? Well, when I look, I can see that the range is about 22 for the lowest number and about 40 for the highest number. So when I do the range, once again, that is subtraction. So I subtract 22 from 40, which makes me borrow, and 10 minus 2 is 8, and 3 minus 2 is 1. So I would write a sentence something like this. The best gas mileage was about 40 miles per hour, and the worst was about 22 miles per hour per gallon, right? Then that puts, so I'm going to either make a complex sentence or I'm going to put two sentences. That puts the range of the gas mileage for these sedans to be 18 miles per gallon. Now, we ask about the interquartile range, the inner grouping, the inner middle 50%. What can be told about the interquartile range? So now I'm going to look at the lowest and highest for my interquartile range, which are the edges of the box. So when I look at the left, I can see that it's at 25, and I look at the right, I can see that it's at 33. So range, once again, is subtraction, and I take 33 and I minus 25, and that tells me that I have 8. So when I look at answering and describing, once again, using words and sentences, I put this into a compound sentence. The middle half of the data falls within the range of 8 miles per gallon, with the worst being 25 and the best being 33. So I have it in a little bit of different order than I did previously, but I'm just showing that it doesn't have to be in an exact format. It just has to be an exact answer with complete sentences. And then the third thing we're going to look at is which is the most consistent. So according to the data, where are the gas mileages more consistent? Are the box data pieces more compacted, more clumped together, or are the whisker pieces? Now, this one gets a little bit trickier because it does look like they would be pretty similar and probably almost equal. But if I use a ruler or some other means of measurements to truly compare, then I can tell that one is indeed smaller than the other. So when I look at it and I start comparing, then I can see that the majority of the data, it's more clumped together in the interquartile zone, right? So if I actually drag these out for you and show you, and I keep the ratio size the same, I can see that the whiskers are a little bit longer than the box. So therefore the box, the interquartile zone, the middle half, is more consistent when it comes to the miles per gallon. All right, so now we go from just finding the median, the lower quartile, the upper quartile for the interquartile range, and we're going to add the whiskers. So now we're going to create the entire box plot. Please understand, these are worth multiple points because each piece of data that you graph on the box plot counts as a point. So when it asks you to construct a box plot, if you don't do that, you're going to miss at least 6 points. And that's going to really hurt your grade. So is this a lot of work? Yes. Is it difficult work? No. It just takes time. And some of you don't want to put in that time to be great mathematicians. I'm asking you to. And not only that, I expect you to. So we're going to start by putting our data in order from least to greatest because that's the way we have to start each and every time. So if you go back and you look at the notes that we did in our previous lesson, I gave you a half sheet of paper so you know how to go through the steps of plotting a box plot. There are 7 steps every single time. If you don't know where this is, you didn't put it in your math book or your math folder like I asked, then there is a copy of it on Canvas announcement for you. First step, order from least to greatest. So I'm going to go through and I'm going to have my numbers from the smallest to the biggest. I would strongly suggest you get a scrap piece of paper or find some open space in your book to where you can write all of this down step by step so you know exactly how to do the work on your own, practice, check. I'm going to have you do in a moment, but then you can look at your homework assignments when I give it to you in our next class period and have all the steps written down. So I have them all listed from least to greatest. And now I find the median, right? So step 2 of creating a box plot, I find the median, and once I find it, then I put a tally mark. So now I'm going to cross out my data from left to right, and I see that's an even set, so I have a middle number. However, that middle number is the same number. So that's going to kind of make my life a lot easier. I don't have to do any math, right? I know it's 25. But notice, since it's an even number, I'm still putting this line here to indicate the median. That's going to be important for steps 3 and 4. So I know that the median is 25 because those two middle numbers are both 25. I put my tally mark above the 25 on the number line, and now I'm looking for my lower quartile. Once again, I go to the left of the median. That is why I have that big long green line where the median is, because I'm going to have to include the left side 25 because the median is a middle number. Therefore, it's the line itself. Therefore, I'm going to be able to cross off left and right. So I do the 19 and 25 as my first group I get rid of, and then the 20 and 23. Then I have a median all by itself. I don't have to do any math. If you don't include that left-hand 25, then your box plot's going to be completely wrong because you're going to find that the lower quartile is 21 because your middle two numbers are 20 plus 22 divided by 2 is going to be 21. And that's not what we're using for our lower quartile. So I'm just stressing that we have to use everything to the left of the median, and that's why we put a line anytime there's an even number of data. So now I make my tally mark, as step 3 says, where the 22 would be on my number line. Now, step 4, I'm going to do the same thing for my upper quartile, and that's everything to the right. And once again, from the line to the right, I have to include that right-hand side 25. So I cross those off, and once again, since it's an odd number, I know that I'm just given my upper quartile, and it's 34. So as step 4 tells me, I make a tally mark. Step 5 is always the same, make the box, right? So when I make the box, now understand, what I would like you to understand is that is your interquartile group. That is the middle group, the middle 50% of all the data that was listed. But now for a box plot or box and whiskers, I have to make the whiskers, right? So the whiskers are found, 6 and 7, is I find the lowest number, which is 19, and I make a tally mark and I connect it to the box itself. My upper whisker, right, or my highest number, step 7, is 40. I'm going to put my tally mark and connect it to it. So now I've created a box plot. So I had work I had to do, and I have plotted 1, 2, 3, 4, 5 different points on the number line correctly. That's worth 6 points. Now I have to answer the question because I have to describe. So what kind of information can I gather from this? We're going to answer those 3 questions. What is the range? What can I tell about the range of the speeds on these country roads? Well, the range, once again, is from the smallest to the biggest number. So I'm going to use it in 2 sentences. Once again, you write in 1 sentence as long as your information is there. The range is speed, or in speeds, goes from 19 miles per hour up to 40 miles per hour. That's a range of 21 miles per hour, right? So there's a difference of 21 miles per hour in that grouping. Well, what can I tell about the interquartile zone? Well, my interquartile zone, when I'm looking at those numbers, go from 22 up to 34. So I write my sentences. The middle half of the speeds goes from 22 miles per hour up to 34 miles per hour. That says the spread of the middle group is in a range of just 12 miles per hour. So now I need to interpret, is my box more consistent or is my whiskers more consistent? And it's not always the box. and it's not always the whiskers. I have to figure out a way to compare them. If I look at them and I use a ruler and I compare them, I see that my whiskers are actually smaller. They're more compacted than the box itself. Or previous to, the box was more compacted. So I write the sentence, the whiskers are more compact than the box. So, well, what kind of information can I get from that? So the lower and higher speeds are more consistent than the middle speeds. That's what we're being able to recognize from this data. All right, so the last question is going to be this check, and I want you to do it. Now, there's a completely separate video just working through this problem alone because I wanted a shorter video taking you through how we find a box plot and we describe the distribution. And so it's about 10 minutes long, but hopefully you'll do this like I'm asking, and then you'll go in and check your work. Make sure you have all the steps. There's still plenty of time left in class. Yes, this is a long video. It's a lot of information, but it's important information for you to learn. Our next class period then, you're going to be given your assignment and have all of these notes that you've taken today in order to be successful. So try this, persevere, do your best, and if you get confused, raise your hand and ask questions, and we'll come around and help.